getting something. All right. So we are getting that, except, see, I never have, I don't know, Miss Pam, did we ever figure it out? But if you hit the SPC button on this, it'll give us an extra decimal. I forget.
It'll give what?
It'll give us an extra figure, okay?
Oh.
And that's probably good because it has it decayed to 118.7 microcuries, okay? And we're getting 120.5 microcuries, all right? Now, what's the procedure manual say in order to do the accuracy test?
It says to use cobalt 57.
No, we don't have that. It
Measure the
says,
background, blah, 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 blah. Record the net activity and repeat for a total of 3 determinations.
okay,
Average of 3. Okay.
here's what we're gonna do, all right? Here. And what I did is I gave Kirsten, that's the last time we did it, okay? So you can transfer this stuff over to this page, okay? But what do we need to identify? What do we need to identify? Now this is on your sheet. It's on 19-7, okay? It is the dose calibrator accuracy sheet. We are keeping log books, okay? We're keeping log books, you know, on our dose calibrators. So what do we need to identify first? I don't like this one actually because they didn't put the institution. So, and I can show them in Dallas what we're looking at here just briefly. But I'm looking at the forms I told you to bring today, okay? That's what we're looking at right there. We're looking at the dose calibrator form. So what's it tell you to identify first?
Manufacturer.
Actually, institution. Okay. So what's the institution?
HCC.
Houston Community College. Don't abbreviate it. There's a lot of, you know, there's Hillsbury Community College. We had somebody from there review our program once. So institution is Houston Community College. The dose calibrator is your what?
Capintech.
Yeah. The manufacturer is Capintech. Okay. The model number is on the front of it. It is CRC-15R.
He's shaking like he's got a palsy.
And the serial number, where do you figure the serial number is?
That's okay.
On the sticker.
No. Where's all serial numbers on stereo equipment and stuff like that? On the back, right? Makes sense? And I guess I could have just read it off the thing. The serial number is back here, and it is 158705. Why is it necessary to do all this stuff?
For accurate record keeping.
No. I'm identifying my dose calibrator, right? Why is that important even in our lab? I got 3 of them. I want to make sure I'm doing the right one. Okay? Okay, so that's filled in. The other thing that we are going to identify is the source we're using. Okay?
So, Mr. Smith,
Yeah.
because of the motion, it blurs every time it moves just a little bit.
All right, I'm going to put it back on the thing. I just wanted, if they've all got the page, they don't need to look at the screen anyway, and I can quit even doing this. Do they all have the sheet that I told them to bring?
Well, they have a blank one. They don't have one that's
No,
ready
that's
filled
all
out.
you need is the blank one, because you're going to fill it out.
Yes,
Okay.
we have it.
You fill it out, and they have a disc, right? So they could make more blank ones if they needed to later, right? I think.
Yes.
Okay, then I'll quit doing that. All right.
Yeah, you'll just need to call the information out to us.
Okay. All right. So the manufacturer of my source is Amersham. Okay. I'll give this back to you because I'll need you to fill it in. Manufacturer is Amersham. This was made in England, so it has a, what is it, a product code and a, I don't know. It's got two, it doesn't have a model and a serial number, okay? But the model number of this one, or the model number is CDR 562. CDR 562. You got that, Dallas?
Yes.
Okay. Serial number is 3181, capital M, capital A. The isotope is cesium-137. The activity is 284.1 millicuries, which looks like they wrote that wrong in there. Yep. No, it's not. I'm sorry. That's incorrect. It's 0.2841 millicuries. It is 0.2841 because it's 284.1 microcuries, okay? But I think we went with millicuries instead here. Okay, and the calibration date is 6/1/1981. So what do we got to do first? Oh, and the half-life, they ask for days. I'm going to keep it years. It's 30.17 years. Okay? 30.17 years. The setting on this, and there's not an automatic button, but the nuclide I have in there is at 220. And that, even on your dial-up, Joanna, is the number for cesium, 220. It's been forever. That's where cesium is set, is at 220. Everything else I'm going to go with the automatic buttons, but that's what you got. Okay? All right, so what we can do now is we can take our 3 readings, okay? So the first reading, you know what, that's the worst. Uh-oh, figures, timing on that.
Just press a number.
Number,
Just press anything.
okay. Good, still sees you.
You can't see it with the lights on off here.
Oh. I thought that would make it better, it made it worse. There's, that's weird. Okay. All right. So, what do you want to put for your first reading? You got to look at that in a minute and make a decision about the average of what you see there. That's going to be your first reading.
Do you want our readings in micro or millicuries?
We can go with millicuries like that. So it'll be, let's go with what? 0.1198 or so. Okay? I'm just kind of doing an averaging in my head where I think it is. Okay? What it does is it tells you to take 3 readings, right? So I don't want to just do that. I'm going to lift this up, turn it around, set it back down, just see if it makes any difference. Okay? And then we will let it steady out again.
1198.
How about 120.0? You know, you just kind of average in what you see, right? Okay. Turn it up, put it around, set it back down.
Mm-hmm.
And you pick a number this time.
119.7.
119.197, right? Good enough? All right. What's it tell you to do next?
Average the
Average them.
readings.
So average those 3. How many figures should you end up with no matter what your average is? 4. Thank you. It should be point something, 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 something. Because why? That reflects the degree of accuracy of this dose calibrator. Okay.
So it's
Although you're seeing when we get that extra.
0.1198.
Okay.
8, and then it's just 3 repeated.
Oh, and that's fine. We're only or 0.1198.
198.
3.
Wait, what happened?
That would be 4 figures, right? 1, 1.
No,
I'm
it's
sorry.
8.
98. 0.1198. That is your average activity. Okay?
And then half-life,
Now,
30.
what was your background?
It's like 0.0.
No, that's your auto.
What did the thing do for you? What did the
Auto
dose
zero?
calibrator do for you? It zeroed it out. So what's your background?
0.
0. So what is your net average activity?
Minus the background, so 0.1198.
It's still 0.1198, right? Because background was subtracted out for you. Now, here's the hardest part of the whole thing. What's your expected activity?
That's the 118, right?
The background we subtracted out was 0 because the dose calibrator did an automatic background subtraction for us. So it was 0. Like Joanna works at a place that has an old dial-up dose calibrator, and she actually has to measure the background and subtract it out to get the net average activity. Okay? But the newer machines, and this isn't even that new, but they always take it out for you so you don't have to deal with it. Okay? But now, what do we need to do? We need to come up with the expected activity, which means what? No. How do you come up with the expected activity?
We watch you work it on the whiteboard.
Oh, isn't that
No, I'm
like
going to
the
have you working on the
0?
whiteboard because y'all are better at something than I am. Because
The
I
0
use a different formula than you do, but I'm going to go with your formula.
The 0.5.
You got activity after an elapsed period of time equals the original activity times what?
0.5.
0.5 raised to what?
Elapsed time.
Elapsed time
Divided by half-life.
divided by the half-life. Okay? So that would be, what's the original activity?
So, Mr. Smith, we can't see that on the board. Do you have the lights on or off?
I have them on.
Maybe you can write it down a little bit, Mr. Smith, because the light is
Yeah.
Reflecting off the board.
reflecting off the board.
How about, can you see it here?
I think that's better.
Alice, can you see it down there? Yes, no, what?
Yes.
Good, okay. Activity after an elapsed period of time equals the original activity times 0.5 raised to the delta t elapsed time divided by t 1/2. This is the formula that's used in radiation safety, right? And you're now using in radio form. So I'm going with your formula. I use a different one, but this is fine. So what's your original activity?
Original activity.
Do you know your original activity? Yes, you do. We wrote it down.
0.2841.
It's what?
0.2841 millicurie.
2841. 284.1 microcuries or 0.2841 millicuries, since we're going with millicuries, okay? Times 0.5. What's delta T? It's the hardest thing. Delta T is, this was calibrated on 6/1/81, right? So we can take that to 6/1/2018. We should make this one 1981. 1981. So how many years is that? Take your calculator and make a subtraction. Go.
37.
How many? 17?
30.
Yeah.
What? 37.
91, 2001,
37.
2011 plus 7.
37.
37. 37 years.
Bless his heart.
Okay?
That's from today's date to that.
But remember, our half-life is 30.17 years, okay? So I want to get accurate to 37 point what? If I'm working with a 30.17 year half-life, I want this elapsed time to be accurate to the what?
2 decimals.
The hundreds place, right? So, what do we need to do? We need to add up how many, we need to put the days over 365 days in a year to get our 2 decimals, right? Okay? So, how many days were there in June? How many days in June?
30.
Minus, right, because we're already there. So 30 minus 1 is 29 days in June. Okay? 29 days. How many in July? 31. If you don't know this, what do you do?
37 times 3.
A lot of us go to our smartphone that has the calendar on it. Okay? How many in August?
Do the calc with the.
30.
Okay, so you got 13,505. Let's figure out.
31 in August. September has 30, right?
Yeah.
September's got 30. October's got 31, because that's Halloween, isn't it? Okay. November's got
30.
30. December, I probably should have gone backwards.
31.
December's got 31. January's got
We're here till noon. It's fine.
31. February had 28, right? And we are when? March the, what's today? 4th. So add all those numbers up.
364. If you want to
Minute?
take, if
Oh,
you're
sorry.
364. If you're taking 1 day off from June the 30th to account for it being 6/1 to 6/1, then that's exactly 364 times 37.
No, he's. I just
What?
realized what he's doing. He's going from 2018 to now.
It would be
To
all the way
today?
June,
Yeah.
so it
Okay.
would be that. So I could have gone backwards and made that 38 minus something, but I didn't. So
Are you adding it?
29 and 31 is what? 60,
Get your shit together, Kristen.
91, 121,
276.
152,
276.
182.
High five, Joanna.
How much is it?
According to my calculator.
How much is it? I quit adding. I hope your calculator. 276.
We like it.
Does anybody
going
else
with it.
agree with 276?
Yes, it's perfect.
Okay, because
It's,
if I get
it's
3
beautiful.
or 4, I start to believe you. Okay?
Wow.
All right. So, what do we do with 276 days?
Divided by 365.
There you go. 276 days divided by 365 gives you. Give me 2 decimals to the right, or 2 integers to the right of the decimal. How much?
0.75.
Oh crap. 175 what?
0.75.
0.75. What's the next digit over?
6.
Then we should have rounded this to 0.76, correct?
No.
You always go to that, but look at the next one, decide go up or down. So 0.76, okay? So it's 37.76 years. That's our what?
Change in time.
Elapsed time. So now we can go 0.5 to the 37.76 divided by 30.17. And what's that give me there? 37.76 divided by 30.17 give me 4 figures.
I have my pink calculator, if you want it.
No. I have mine too. I just don't feel like doing it.
How much?
Okay.
I don't know. I can't do it in my head
Yes,
here.
you can.
I want 37.76 divided by 30.17. It's going to be a little
1.25.
1.25
2, 5, 1,
1 1.
6.
6.
Then 2, rounded to 2.
No,
Got
no.
four figures, how many
252 is what he's doing. Yeah.
Cool. So let's stay there.
Oh, okay.
Okay, now, y'all that have been working with this, give me not 0.5, what did I do here? That should be 0.5 raised to that power. Give me that. It should be about 4 tenths.
Ouch.
Because it's more than a half-life. You keep that number in your calculator. So what is 0.5 raised to
It's
1.252?
Oh.
0.41.
0.419
9.
what?
8.
8. What's to this right of the 8?
6.
Oh, I'm sorry.
Then 9.
0.419.
0.4199, which I believe, here's why. It's more than a half-life, right? So it's got to be less than 0.5. So I know mathematically that makes sense. A lot of you do math. You get an answer, you put what your calculator said, and you don't step back and say, does my answer make any sense? Okay? That makes sense that it's about that. Now multiply that number by what? 0.2841 millicuries. And we'll know what the decayed amount is. So what did you get for an answer? Should be about 0.12 or 3, something like that.
0.119.
Okay.
1193.
So we got 0.1193
3.
3 what?
Millicuries. No, it's 0.
You got another number?
No, because it was 2, and then the one next to it was 9.
So it'd be 3.
So
Okay. This time you did round it correctly then. Okay, that's why I was asking you what the number was. And that is millicuries. That's what? What's that number?
That's your expected activity.
That's your expected activity. Why do we expect to get that? Because 37.7 years, 37.76 years ago, we paid good money and they guaranteed us what? That it was 284.1 accurate to within plus or minus what percent of the stated value? 5%. Remember, you buy it and they guarantee it, traceable to NIST standards, okay? So we know this is correct. What are we testing? Accuracy of the dose calibrator, right? So now, okay, so what does it ask us to do next?
Percent error.
Percent error. So what do we do? Okay, I'll erase my dates. I got to remember so Dallas sees it, not to stand in the way of what I'm writing here. But we got what? Percent. How do we do that? What's the formula? What do you think? You only got 2 numbers to work with.
Average activity.
So you're testing the dose calibrator, not the accuracy of the source, right? So you take measured minus calculated over calculated. So what's the measured value that y'all got? That is what?
Your average?
That's your net average activity, which is, what did you say it was again?
0.1198.
0.1198 millicuries minus what? Oh, this is ridiculous. Close. Point
Minus
what?
1193.
1193 millicuries. That's our expected over what?
0.1193.
Measured minus expected
Over expected.
over measured.
Oh.
Oh.
Because that's guaranteed to be the number. So that is point.
I just like to be wrong.
I'm sorry, that's
Accepting I
incorrect.
Yeah,
Wait
it's
a
over
second.
expected.
It's expected.
Yeah.
Circle back around.
that's the one that is
He
guaranteed
likes
to
to
be
be one
that,
too.
right? So 0.1193 millicuries, and then we're never happy in nuclear medicine unless we do what at the end?
Times it by 100.
Times 100 to make it a percent. And you
So
gonna get,
Mr. Smith, it's measured minus expected?
oh, measured, well, expected, or,
Net.
I'm sorry, wait a minute.
Is it
Yeah, measured by, no, I'm sorry, that's wrong.
net average minus
Let me go with this. I apologize. Measured minus, I should write what I say, not what I wrote. Measured minus what? Calculated over calculated. What did we calculate? We took the 284.1 indicated out for the 37.76 years. Okay? So measured minus calculated over calculated.
500, and what'd you get?
I don't know.
Right,
And you know
calculated,
what?
Because we're not using that.
Because I don't see why you should have to memorize like 10 different formulas. You know, you could go with the well counter, go with today's minus yesterday's over yesterday. And over here you're going measure minus calculated over calculated. You really ought to go with measured minus expected over expected, and then just what is the expected? What is the expected? The expected is your calculated value. What was the expected on your scintillation well counters? Most recent measurement, okay? You're always testing the dose calibrator or the well counters or what you're getting today and comparing it with what you got the last time or your calculated values, your expected values. Your expected is you paid good money and they told you that it was accurate. So you're comparing against that measured value. You're checking your dose. Maybe your dose calibrator's way off. Who knows? Okay? Obviously it's not with those kind of numbers, because that's like what? 0.0005 divided by 0.1193 times 100. What do you get? Probably get like
0.419 or 0.42?
It's 0.419.
okay. I was even thinking lower than that, but okay. So the difference is point what?
0.419.
0.419
1.
1%.
So that is the correct formula.
What do you think?
So
what do you
that is the correct formula?
Mr. Smith, could you move over just a moment?
Yeah. Yeah.
Well, it's in that plus or minus 5%, so it's still okay, right?
Even the toughest standard would be what?
10%.
No, the toughest standard might be plus or minus 5%. Your lesser standard might be plus or minus 10%. That is well within any national standard or the manufacturer's recommendation. And that's using a 34-year-old thing with the dose calibrator. There's probably, I don't know how old that dose calibrator is now, probably 12 years old. So that's a pretty good number, okay? That's a very good number. All right?
Oh,
So that's it for that. That's not it for this page, right though?
That's it.
Nope. We got to know who to blame, so what do they put at the bottom of your page? Signature. So you can put yours in, okay? Because that is who. That's the, you can put, I guess you can put my name too, but we'll pretend like you did it because you watched it anyway.
Baker.
That's the individual who did the test, right?
Me.
And then you got today's date is what?
The 4th.
4. And then what is your
Next.
next calibration date?
Next year.
Next year, okay? However, that you probably should pull out your iPhone, make sure it's not what?
A leap year.
Saturday or Sunday. Okay? So I would pull out my iPhone. I can do that. You can do that. Pull out your iPhone, make sure that March 4th the next year isn't a Saturday or a Sunday.
It's a Wednesday.
Hey, we're set, so you can put it. However, also in my iPhone or your smartphone, I'd also put what?
Reminder.
I'd put that date, and I'd put my alert to be a week before that date, so that bells and whistles or something on my computer goes off to tell me. Because the hardest thing is when you're only doing this once a year, it's what? Remembering to do it. It's not on the top of your mind, so you better have something signaling you